Hi, students, feel free as usual. We are meeting here for discussion in mathematics. If you remember by the video I've had in the past, and you are encouraged to do so, revise them out. We have been discussing about the logarithms. And in the previous one, that the video which you just watched, there was a discussion about further application of the laws of logarithms. Right, so what is there? Just a matter of asking you to always revisit these areas, revise it, and be able to understand all the laws and be able to know again how you can use them. So the whole discussion we have here is there emphasizing the point on how best you can use the laws of logarithms we've discussed to solve some problems. Right, so we have had a lot of problems here, and you have seen how we are using the laws of logarithms to come up with solutions, of which this time around we are going to end up with the three examples in the phase application. What you need to understand, just like there are several different sorts of, there are several problems that you're going to meet, and you should be in the position how best you can decide which law can be applied in order to come up with the solution. So here is the last that's a setup of the type of question you should expect to come with an exam or wherever you are interacting with the issues related to exponential and logarithms. Without wasting time, let us get started. We may have problems which can come like this, where you always be discouraged to use the calculator, as it was in the past video. We had that example. So some problems will be like they'll give you a logarithm of certain numbers, and they'll ask you to find the logarithm of other numbers. Right, like say for example in this one we're given that logarithm of a 2, right, is 0.30103, and you're also given logarithm of a 3 is 0.477212, and logarithm of a 5 is 0.69897. This is more like by use of calculator. Now here we are, they say in your case we should not use a calculator, and now you are asked then to work out the logarithm of a 6, logarithm of a 50, and logarithm of 2.5 without using a calculator. Right, so now it's just like now to such type of problems, how do we approach them and how do we handle them out in order to come up with the solutions? Right, so now by the virtue of the knowledge, as a student, I think to some problems, though we have not given you the solution to which, you can be able at least to analyze up this the problem and be in the position then to come up with the methods, or say talk of the procedures on how we can come up with solution of which. Like say for here, like here, you are told the logarithm of a 2 is this, logarithm of a 3 is that, logarithm of 5 is this, and you are asked now here to work out for a logarithm of a 6. Just like now without a calculator, how can I find the logarithm of a 6? So as a student, you should be able in the position to think logically and very deep about the concepts which I've already read in the past. Like say for example, that wasting time, since you are not here with me, I'll just perceive that you are somewhere to, that's one way on how you can be able to think and reason. I know you may also have some other approaches. Logically, you may be able to realize if I need to find the logarithm of 6, it means now here I have to use what I'm given here. I have to use logarithm of a 2, logarithm of 3, or logarithm of what? Of a 5. So that takes you into a situation whereby one area of concern, you can decide to express that logarithm of 6 into factors of 6 as such. Right, for you to use what you are given in the question here. So like log of a 6, one can decide by to write the log of a 6 in the factor form like log of 2 times 3. Like that. Much that you are doing that, you're expressing that number into certain factors, you should be able to at least relate with what you are given there. Like say you can talk of factors of 6 that are several, you can talk of 6 times 1, you can talk of 2 times 6, etc. So, but now you are looking at say, what factors can I have, or say, how best can I handle this in such a way that I should use the information given in the question here. So I've decided to use the factors of 6 being in 2 and 3, not 6 and 1, because of the reason that I can see here that there is logarithm of a 2, and somewhere there's logarithm of what? Of a 3. So what it means for I to meet the situation that is given in the question here, in order to handle the logarithm of a 6, what it means, when I write log of 2 times the 3, this simply means a situation that we have had in the past when we can relate that one to the laws of logarithm. What I've written here is as good as writing logarithm of a 2 plus logarithm of a 3. You remember the laws of logarithm, that to say if I've got logarithm of numbers which are adding but they're expressed with the same basis, is just as good as multiplying. Like here, log of a 2 plus logarithm of a 3 is as good as just multiplying 2 multiplied by 3, while this one is expressed with the same base. Right, as here, we already know that the base here is the 10, base is the 10, base is the 10, but only that here is not visible. So I'm trying to relate what we have learned about the laws and also with what we're given in the question here, in order to handle up a situation about the solution to the logarithm of a 6. So this is one way how you can do it. Express a number into factors like that. But when you do that operation, try to be able to meet a situation above the laws, because you cannot just solve these ones without applying up the laws of logarithms. So here, log of 6 is equal to log of 2 and 3. I hope we are all there. Writing this and that are the same. But when I write this, according to the laws of logarithm, this simply means log of a 2 plus log of a 3. So now you can see what we have here. It means if I talk of log of a 6, I'll be talking of this situation, which then, if I'm going to come to the question, I find that log of a 2 can be substituted by this value here. So it means wherever I have got log of a 2, I'm going to write 0.3010. And where I have logarithm of a 3, you see, it's already given here, which is 0.477212. So here I'll write 0.477, then what? 212 as such. So when we add this one here, you'll be in the position to find the logarithm of a 6. Just add this one by that one and find the solution to that. And I think there's no need for I to come and work out for this one. It's too simple. Just get the calculator and do the addition, and that what you get is the logarithm of a 6. By what I have here, you can just go to that one. You have that the logarithm of that number is equal to 0.77815. Right. So which means each time you can have a situation like this, given the log of a 2 is this, log of a 3 is this one. If you need to work out the logarithm of a 6 using log of a 2 and using a logarithm of a 3, you'll be able to find that logarithm of 6 is this number here. Simple as that. Right. Done with that, let's now go to example B in the same situation. We don't have a logarithm of a 50 here, but now you're asked to work out the logarithm of a 50. You see now, no use of a calculator. How do we do that? So at least with what we have just done with the first example, you can be in that track to see now if I have got a 50. And now if maybe I would think of taking the same stance as what I've done by example A. What can I do with the 50? Right, so let's see what will happen with the 50 if I'm to select some factors of 50 by what we have in here. Will that work? As here I selected the factors of 6 here as 2 and 3, I'm able to come up with the 2 and the 3 in the form of log of a 2 and the log of a 3 that I here have substituted. Now, what about logarithm of a 50? Right, so let's see what it is there. Right, so for B here, we have logarithm of a 50, but now, if you can look at the 50 as such, you'd see that it's not all that direct, that you may be able to come up with the factors of 50 as by what we have done in example A to meet what we have here in the question. Like say if you look at 50, you'll be talking of 25 times what? You can talk of 25 times 2. You can talk of maybe 5 times what? Times 10. You can talk of 50 times what? Times 1. All those situations. So just like now, out of this, if I'm to maintain the stance what I have at the beginning there, how best can I handle that one? Right. So whatever you do here, when you're selecting up the factors, be able to see that those factors you have selected are going to help you. If I take a 50 and a 1, do I have got a logarithm of a 50 there? If I'm going to follow the laws of logarithms, you find that here we don't have a 50. What about a 1? We don't have logarithm of a 1. Right. But now, if you talk of a 5 and a 10, am I going to work out for the log of a 10, of a 5, and logarithm of a 10? What about the 25? Can I have the logarithm of 25? Can I have logarithm of a 2? So if these things are present in here, If they're not sometimes present, then can you bring us some issues that are related to the laws of logarithms? If you insist to handle that factor by what we have done here, but you see that here we don't have the logarithm of that number or that factor. Right, so that's the way we do. You either bring in a concept as much as you see that what information you're given here is not enough, but it should be within the laws of logarithms, or else it should be direct here, as we have done example A, as we are just substituting there, things were just fine. Now here, if we are to maintain what we have done A, you'd see that if I can express 50 into factors of 25 times 2, this one will hold. And if I can also do for the 5 times 10, you may also see that this one is also what? Going to hold. So it means I've got two situations here that can meet up the logarithm of 50. Either you can express 50 into 2 times 5, in 25 times 2, and also in 5 times 10. So somebody will say, how are we going to handle the two? Because here we don't have log of 25, and here we don't have logarithm of what? Of a 10. Right, so I'm just going to discuss with you on that part, because the rest of the story is just historical, and you do as we have to have done in example A. It's just a matter of substitution. So why I choose this situation and that situation is for the reason that if we go for the laws of logarithm, for example, if I can take 25 multiply by a 2, this simply means I have like logarithm over 25 times a 2. This will be what? Though I don't have 25, I will know for sure that this 25 is as good as writing logarithm over 5 to the power 2, then multiplied by a 2 itself. Look at that. So when I'm going to borrow the rules of logarithm, this multiplied by this is as good as writing logarithm of 5 to the power 2, then plus logarithm of what? Of a 2. For this one here, we know that the base is 10. By the rules of logarithms, you can look at logarithm law number 3 if you have copied, or else if you are still having those videos right away now, you will be able to apply that. You see that law number 3 demands you to have these two coming towards this side, and you have got a 2 here, logarithm of a 5 plus what? Logarithm of a 2. So what is it that we're going to do here? You're just going to substitute for logarithm of a 5, which is this one. You multiply by a 2, then you add with logarithm of a 2, which is given here. At the end, you have got a situation that meets up the logarithm of what? Of 50. So somebody who does this one, there's no problem, it's okay. But on the other hand, if you don't want to take this one, I know here you can finish. Take this one on your paper and try to finish just by substituting for this and that. Right. For the other part, one may say, no, I will not go by that. I can have logarithm of 50 by expressing 50 into factors of what? 10 and 5. For the sake that I know log of 5 is here, if I'm going to express this one into laws of logarithms. So what I have here, it will be like logarithm of a 10 plus logarithm of a 5. That's what will be there. Now, here I don't have log of a 10. But understandably, you'll be able to also check the last law, which I gave you in those laws of logarithm. Tells us logarithm of a 10 is just like log of 10 to base 10, and the answer is 1. So for the 10 here, you just write and indicate a 1. Plus log of a 5. What is that? Log of a 5 here is this one here, which is 0.69892. Look at this one. We are not given log of a 10, but we, using the laws of logarithms, we are able to meet the log of a 10. You see that? So here it means instead of writing log of a 10, substitute that one with a 1. Logarithm of 5, you're going to substitute it with a 0.69892. What do you have at the end? It'll be like 1 added with this one, which gives you 1.69892. So this is a logarithm of 50. Right, using information we have it here. Right, so you see that? Right, so you are at least be able to now get more meat now in terms of knowledge on how we can approach different problems in what? Logarithm and exponential. Like I'm doing it right away that say everything that you're supposed to know. Here we're discussing it and we'll leave in nothing. Right. The last one is the problem here. Now it's the decimal number. Right. So let's look at it and how we can hand that one out. Right. So we have solution for C. We are given log Let me write on top there. Now, logarithm of 2.5, log of 2.5, that is C. Right. In the same vein, you can still at least come up with the application to that based on what we have just experienced in the example 1 and the example A and B. So this one, I think it's not easy for you to come direct just multiplying with a certain factor by another factor to get up the two factors of 2.5. You may not have any substitute in this case here. But now if you can bring in some kind of application by first of all rewriting that number 2.5 in another form, you have a direction towards it. So like here, one can think of rewriting this one as 2.5 giving us what? 2, 5 over 10. Which is just like here 1, here 2, which is as 2.5. The very end I've got 2 times 2 get a 4 plus 1 is a 5. So here this is the same as logarithm of a 5 over 2. That's what it means here. So 2.5 is as good as writing 5 over 2. So once now we have got that situation, then law number 2 about the addition and subtraction is that's a division and subtraction is going to hold order there. So if I've got two numbers dividing there, but expressed to a certain base like a 10, this case already base the 10, that simply means the logarithm of a 5 minus logarithm of a 2. Right. So what do you have for logarithm of 5? I can see it here, which is 0.69897 minus log of a 2, which is this one, 0.30103. Right. So if you subtract that, you'll be in the position to find the logarithm of 2.5. I think we can just subtract it directly here together. Talk of 0.69897 minus 0.30103. So what do you have here? 7 minus 3, you get a 4, here you get a 9, here you get a 7, here you get a 9, here you get what? That's a 3, and then here we have a 0. Right, so for this one, it means what we have here, we'll talk over, that's a 0.39794 at the logarithm of 2.5. Right, so you can see, just simple, much that you understand the laws. So please, this approach and the previous approaches that we have had in the previous videos, please let us master them. As I always ask you, do not memorize the examples, but master the logic. That's the content, and also the skills as such. How do we handle this? How do we handle that one? So similarly, you'll be meeting several problems. Try to approach them like that. So I think as a student, sometimes try to master the questions themselves, the way they come. To say a question comes like this, how do you handle them? So definitely when you're given a logarithm of numbers like this one, you know that, oh, this is the way we do. Finding factors, or say come up representative of a particular term, it goes like that. Right, so now this is what we have had there. So I'll also leave you an exercise for you to write, only 2 questions for this. Right, so it works better if a teacher teaches and you also try. No, maths is not about the preaching. You need to at least listen, capture the knowledge, and thereafter you do the practice. So at the very end, can you have this one out? The lab here. How would you approach this? Right, exercise. Here we have this one. Suppose you're given, let me just be brief somehow. Given logo of a 2 still more is 0. I would have just left it like that, just give you the question. Anyway, it's just okay. 0. That's a 30103. And also have logarithm of a 3 is equal to 0.47712. The same information. Logarithm of 5 is given as 0.69897. and we're adding logarithm of the 7, given as 0.84510. So without using a calculator, can you work out the following? A, you have to work up log of 45 over 7. B, have this one, half logarithm of 81. And lastly, can you have this one here? Talk of what? Log over 3.5. Right. Just work out on the 3. By the time you handle this one, and that one, then think life is better for each one of us here. Thank you very much for this. What we are remaining up here now is just the last part. So I want you at least again to be together and close the topic. And the last part is just about solving the equations. Right, that's the logarithmic equation, which we have not had. So let us see how we can solve the logarithmic equations that we can have here. The type of equations which cannot demand what we have had there by expressing for the terms the same basis or whatsoever, expressing the talk of the logarithmic equation to exponential. Let's see what we have here in the next video. Right, thank you for being together, and I'm waiting for you in the last chapter.